Hello and welcome to this video. In this video we're going to take a look at how we're going to calculate some areas of some more complicated shapes. So we should be familiar with some areas of some simple shapes. So things like working out the area of a rectangle or a square is just knowing the area is the base times height, and this works for rectangles and squares because the only difference between a rectangle and a square is that a square is a form of the rectangle where both of the sides are the same. So in the case of a square, base and height would be the same number, but the way we'd calculate the area would still be to just multiply the two sides together. We could go on to slightly more complicated shapes. We might get something like a trapezium, for example. We could have a trapezium that looks like this, where I could label this as A, and this is B, and this is H, and the area of a trapezium is half A plus B times H. Then we could also look at things like areas of triangles. So let's take a right angle triangle. This works for all triangles though. This is the base, this is the height, and our area of the triangle is going to be half times the base times the height. Now it's halved because this is essentially just, if I were to draw another thing here, we'd get back to the rectangle. And so what we're saying is that a triangle is basically two rectangles, or even a rectangle is two triangles that have been connected together like this. But in the case of just the triangle, we're just going to say that it's a half base times height. And these are the ones that we're going to have to concern ourselves with when we look at most of these compound shapes. It is possible for us to also have shapes that include some circular parts, but not necessarily a full circle. Since if it includes a full circle, it's very difficult to make it a compound shape. So maybe look at the hemisphere. So let's say this is a hemisphere with a radius, which we're going to call r. So this distance from the very center of the hemisphere to the edge, to one of the edges, is r. And the area of a hemisphere is going to be the area of a circle, which would be pi r squared divided by 2, because we've just taken the whole circle and we've just cut it down the middle, and now we've just got half of this circle. Okay, so now what would happen if I were to put together a few of these shapes and make a more complicated shape? So maybe I could get a trapezium. So let's start with a trapezium. I could have my trapezium here like this, and I could maybe put a right angle triangle back to back with this, like so, and then I could put a rectangle on the top, and then maybe I'll put a very large semicircle at the bottom here. Draw that a bit better. And they might ask you to calculate the area of this shape. Now, essentially, we haven't changed anything. All we've done is change the fact that we've just added them together. And so that's exactly what we would do. We would find out the area of shape 1, the area of shape 2, area of shape 3, and area of shape 4, and we would just add them together. And so the way we're going to do that is the area of 1. Let's say that this would be maybe 5 centimeters across here, and we'd find out that this might be let's say 2 centimeters up. So area 1 would be just 5 times 2, which would give 10 centimeters squared. Area 2, we'd find that this is also 2 centimeters here, and this base is actually 3 centimeters. So the area of that right angle triangle 2 would be 3 times 2, all divided by 2, which would just be 3 centimeters squared. Then from 3, what we already know is that this side here is 5 centimeters because of 1. And we know the height already because of this right angle triangle. And this base is going to have to be bigger than 5. So let's say that this base happened to be 8 centimeters. Then shape 3 is a trapezium. So we would say that this is A plus B, so 5 plus 8, all divided by 2 because of the half at the front, and then times by the height, which is 2, and so the 2's will cancel, and so we'll just get 5 plus 8, which is 13 centimeters squared. And then finally, since we know the diameter of this circle is 8 centimeters, in order to work out what the radius is, we just have to half the radius, and so our area is going to be pi times half the diameter to get the radius. And half of 8 is 4, so pi times 4 squared, and then divided that by 2 since it's a hemisphere or a semicircle. And when we do that, we get 16 pi divided by 2, which becomes 8 pi centimeters squared. And in this case, I'm going to leave my answer in terms of pi. But then if I want the whole area, all I have to do is add them up. So area is just going to be the sum of all of these things, which is going to be 26 plus 8 pi, which is actually going to give you a value of about 51 centimeters squared. So nothing too complicated here. All we've done is taken simple shapes, and in compound shapes we're just going to layer them on and try and work out the total shape. But in your exam questions, they're probably not going to tell you that this is a trapezium connected to a right angle triangle connected to a square or whatever it is. They will just give you an example of a shape. So they might say that this is your shape, and work out the area, for example. And they'll give you some lengths and sides, and then expect you to be able to work out the area. And the trick to this is just noticing what shapes is this compound shape made up of. And in this case, I could draw a line across here that would split this into a trapezium down here and a rectangle up here. And then using the dimensions that they've given, I would simply work out the area of the rectangle first, then work out the area of the trapezium, and then take both of these things and add them together, and that would give you your total. So the first thing you need to do is recognize the shapes. Then the second thing you need to do is calculate the areas. And then finally, sum all of the areas. Hello and welcome back to another video. In this video we're going to go through some exam practice on how we would calculate the areas of some compound shapes. Okay, so first up we have a shape where they've already quite nicely outlined the fact that it's split into a rectangle and a triangle, and they want us to work out the total area of this shape. So what we said before with compound shapes is that the point of a compound shape is that it's multiple simple shapes just have been compounded together. In this case, we can probably see that that's a rectangle and a triangle. So first we need to work out the area of the rectangle. So a rectangle is going to be the base times the height, which is 7 times 5. So this is going to be 35 centimeters squared. So the area of the rectangle is 35 centimeters squared. Next we will have to find the area of the triangle, and the area of the triangle we said was a half. So if the area of the rectangle is base times height, the area of the triangle is a half base times height. And the base is 4, the height is 5, since if this side of the rectangle is 5, then this side must also be 5. So this is 4 as a base, 5 as a height, which would give us half times 20. When we do 4 times 5, we get 20. Taking a half of that, we get 10 centimeters squared. In order to find the total area, we're just going to take the A rectangle, the area of the rectangle, plus the area of the triangle, which is going to be 35 plus 10, and so we get 45 centimeters squared for this area. This is a relatively straightforward example of this, because they've broken down already for you the fact that it's a rectangle and a triangle. They don't always do that, however, so sometimes they might tell you that it could just be this shape and expect you to be able to break it down. So let's take a look at this second example. So it shows a rectangle inside a triangle, and the triangle has a base of 12 centimeters and a height of 10 centimeters. The rectangle is 5 by 3 centimeters. Work out the area of the region shaded in the diagram. So this compound shape, instead of adding things together, we're going to be taking things away. But we're still, just as in the previous example, we still only have to worry about the area of the rectangle, which is base times height, and the area of the triangle, which is a half times the base times the height. So let's work out what is the area. So I'll do it over here, area of the rectangle first of all. Okay, so the area of the rectangle is base times height, where the base is 5 and the height is 3, given over in this diagram here. And so that's going to be 15 centimeters squared. And then we can put that aside. Then the area of the triangle is a half of the base times the height, which means we've got a half times 12 times 10, which is going to give us a total area of 60 centimeters squared, being the total triangle. So now if we want just the shaded region, we need to take the total triangle and then get rid of this rectangle shape here. So the area of the shaded region is going to be the area of the triangle minus the area of the rectangle, which is 60 minus 15, which is 45 centimeters squared. So the area of the shaded section of this triangle will fill out an area of 45 centimeters squared. Okay, and finally, in a more practical but also a slightly more difficult example, this diagram shows the floor plans of Mary's conservatory. Mary is going to cover the floor with tiles. The tiles are sold in packs. One pack of tiles will cover 2 meters squared and normally costs £24 and 80 pence. Mary gets a discount of 20% off the cost of the tiles. She has £100. Does Mary have enough money to buy all the tiles that she needs? You must show all of your working. Okay. First thing we have to do is work out what actually is the area of this conservatory floor. We could do this in a few ways. So, for example, we could recognize that if I were to draw a line here, that would give a trapezium here, and I could also draw a line here, and that would give a trapezium here, and we'd be left with a rectangle in the front, in the middle, and then we'd have to simply do the area of this trapezium plus the area of this trapezium plus the area of this rectangle, is one way that we could approach that. Now, the second way we could approach it is to just place this across here like this, and then we have this half down here is a rectangle, and this half up here is a trapezium still. And so I would say this is probably the easier way to do it, because it breaks it down into being just 2 shapes rather than multiple shapes. and the less shapes you have to work out the area for, the less likely you are to make a mistake in any of your calculations. So we have to worry about what is the area of a rectangle again, and that's base times height, and then we have to worry about the area of the trapezium, which is a half of a plus b times the height. Now the area, I should probably make this a more explicit trapezium, like that. The area of this rectangle, I'm just going to call it AR for now. So the area of the rectangle is the 3 meters across multiplied by 2.2 meters going up, gives you the area of this total thing, and that's going to be 6.6 meters squared. Then the area of the trapezium, which I'm going to call AT, the area of the trapezium, is going to be half times the base, or A plus B. So B is 3, A is 1, so 1 plus 3 is going to give us 4, and then multiplied by the height. Now the height is, since I know that up to this point is 2.2 meters, and then up to this point is going to get us that 3.4 meters, I have to look at what the difference between these is, and that's going to be 1.2 meters. So I'm going to multiply that by 1.2 meters. And when we put all of this into a calculator, you should find that this is going to give 2.4 meters squared. And so in total, so the area of the total is going to be the 6.6 plus the 2.4, which is going to give 9 meters squared. Now, since we have 9 meters squared, now we can look at how many tiles are we actually going to need, how many packs of tiles are we going to need. And so if we were to do 9 divided by 2, since we know we're splitting this 9 meters squared up into sections of 2 meters squared, 9 divided by 2 is going to give us 4.5 packs. However, we can't go to the shop and buy half a pack of tiles. We have to buy them in the full amount, and so this means that we're actually going to have to buy 5 packs, because we can't just take out half of the tiles and then walk away with those. Okay, so now if we've got 5 packs, and those 5 packs each cost £24.80, then we can work out the total price. So 24.80 multiplied by 5 is going to give you 24.8 times 5 is going to give you £124 in order to buy 5 packs of these tiles. However, Mary gets a discount of 25% off the cost of the tiles. So what we can do is then work out what is the reduced price of this. And so there are, again, multiple ways we could do that. We could work out what is 20% of this and then take 25% of this and then take it away. Or we could find out what is 75% of this. Since we know if this is 100% and we're trying to get a discount 25, we're just going to get the 100 minus the 25, which is going to give us a 75% left over. And now if we make a little side note here, 75% is the same as saying 75 divided by 100. That's what percent means. So we get centuries because it's 100 years, and having a percent means it's 75 out of every 100. And if I were to put this into a decimal form, then it would be 0.75. And so what I can do from there is I can take this 0.75, and if I multiply that by this 124, I end up working out what 75% of this value is. And so when I work out what 75% is, it gives me a price of £93. Now Mary has £100, and we're asked, does she have enough money to buy all the tiles she needs? And the answer is yes. She only needs £93. And there you go. This is how we're going to work out areas of compound shapes, and even using those to push a little bit further into more practical everyday uses. Hopefully this helps, and I'll see you next time.